So our universe is expanding. This isn't news. You probably knew that. But what might be news to you is the fact that the expansion of the universe is speeding up. And scientists think they know why. It has to do with dark energy, mysterious stuff that makes up 70% of the universe, but which we can't see or interact with in any way. Dark energy is a complete mystery, but we have some ideas about it. And one idea in particular could determine the fate of our universe, and of course, our fate along with it. In this episode, we're going to talk about the accelerating universe and how dark energy could tear our reality apart. Let's get into it. If you're watching this video in 2022, I want to wish you a happy new year. May all your supernova be of the type to variety, and may your neutron stars be made of pure dark matter. I don't know. That's about as good a New Year's wish as any other. Anyway, let's get into this accelerating universe business. When scientists started looking at distant galaxies and measuring how far away they were, they noticed something strange. Most of the galaxies seemed to be receding from us, and the farther away they were, the faster they seemed to be moving away. They weren't just moving away, they were accelerating away from us. This is weird, because if you think about the universe like a giant balloon, then everything on the surface of the balloon is moving away from everything else as the balloon inflates. But in that scenario, things wouldn't be accelerating away from each other. If anything, things would be slowing down as the balloon's surface starts to stretch more and more. So why are galaxies accelerating away from us? Scientists came up with an explanation. There must be some kind of force pushing things apart. That force is called dark energy. In fact, it's been given a name even weirder than dark energy. Scientists call it quintessence. No, really, that's its name. Quintessence. Here's what we know about this hypothetical quintessence. First of all, it's a kind of energy. It has pressure, and the relationship between the two is weird. Usually when you have something like a gas, for example, the pressure is positive. But for quintessence, the pressure is negative. And that's weird. Physicists are used to negative pressure. They've run into it before in their study of subatomic particles called scalar fields. These fields, much like the hypothetical quasar field, have a kind of negative gravitational resistance. You know how if you put two masses together, they attract each other gravitationally? Well, a scalar field does the opposite. It pushes back against gravity. So, in effect, it acts like a kind of anti-gravity. But here's where things get weird. A negative gravitational resistance doesn't just push stuff away from each other. It also causes stuff to accelerate away from each other. And that's what scientists think is happening out there. The hypothetical quintessence field is causing galaxies to speed away from each other at an ever-increasing rate. Now, you might ask yourself, why does this field exist? And the answer is, we don't know. We have no idea. But we do have some guesses. For example, quintessence might be related to the cosmological constant. Now, that sounds confusing, because physicists use the cosmological constant to describe a different thing, and we'll tell you about that in a minute. But the point is that the cosmological constant is a type of dark energy, too. And the cosmological constant doesn't change over time. It's always the same, whereas quintessence could change over time, could increase in strength. And that means the expansion of the universe could get faster and faster. And that brings us to the heat death of the universe. Well, actually, it brings us to many heat deaths of the universe. See, there are several scenarios here. Let's imagine a flat universe. One where space is neither positively or negatively curved. In a flat universe without dark energy, the expansion of the universe will slow down until gravity eventually takes over and pulls everything together in a big crunch. But if there's dark energy, then the expansion of the universe will speed up. And if it speeds up enough, it will overcome gravity entirely. That's what scientists mean when they say the heat death of the universe. Eventually, everything will drift away from everything else so far and so fast that nothing will ever come together again. It's kind of like heat death, except it's not really death. Like, I don't think anyone's coming back from this vacation. But a flat universe with quintessence is only one possibility. There are others. If the amount of quintessence increases over time, then the expansion of the universe could speed up faster than this heat death scenario predicts. That means our universe could rip apart. Not like the Big Bang, but slowly and steadily getting bigger and bigger. The space between galaxies would stretch more and more until the light inside of galaxies would get stretched beyond the red end of the visible spectrum, and then beyond infrared, radio waves, and then it would become invisible. You'd watch the night sky grow darker and darker until every star was out of sight. Or maybe our universe will expand forever at a constant rate. That's what the current evidence suggests. That's called the Lambda CDM model, where lambda is the cosmological constant and CDM is cold dark matter. The lambda represents dark energy, that mysterious stuff that makes up around 70% of the universe. The CDM represents the stuff we can actually see, stars and planets and people and stuff. In the Lambda CDM model, the universe expands at a constant rate, and the amount of dark energy doesn't change over time. That means the expansion of the universe will never flip and collapse. It will simply continue indefinitely. So those are the three possible scenarios for the fate of our universe: heat death, the Big Rip, or indefinite expansion. Here's a bonus scenario. None of those things will happen because the universe isn't really expanding at all. Some astronomers believe the recession of galaxies is an illusion. They say it's caused by something called tired light. Tired light is basically the idea that light gets redshifted as it travels through space, and that redshifting makes distant galaxies look like they're moving away. It has nothing to do with the expansion of the universe. Unfortunately for tired light, there's no evidence to support it. The recession of galaxies fits nicely with the Big Bang model, and there's no evidence against it. So we can safely ignore tired light. So the fate of our universe likely comes down to this thing called dark energy. What is dark energy? Well, scientists don't really know. They've measured some of its properties, but they don't know what it is, where it comes from, or why it exists. There are a lot of guesses, though. Physicists think dark energy could be a kind of field, and I explained earlier how a field could cause the acceleration of the universe. Another idea is that dark energy is a kind of particle. But if it is a particle, it's probably a really heavy one, because it seems to be constant throughout space. That rules out most of the subatomic particles that physicists know about, like electrons and quarks. Those particles have masses on the order of a few electron volts, whereas the hypothetical dark energy particle would have a mass on the order of billions of electron volts. Finally, dark energy could be related to vacuum fluctuations. Quantum mechanics says that even a vacuum is really a seething mass of virtual particles that pop in and out of existence. Maybe the energy of these virtual particles causes the expansion of the universe to speed up. So those are some possibilities, but no one knows which one is correct, if any of them are correct. The problem is no one knows how to measure dark energy or detect it in any way. The only evidence we have for it is the effect it has on the large-scale structure of the universe. So here's the bottom line. As far as we know, the expansion of the universe isn't speeding up, but it isn't slowing down either. So everything seems to be cruising along as predicted by the Lambda CDM model. And that's good news. If the expansion sped up, we'd be in trouble. We'd all be torn apart when the universe ripped, or we'd be flung into the abyss of eternal darkness. So let's keep things the way they are, shall we? Talking about dark energy, because it's such a big deal in physics. After all, it makes up 70% of the universe. That's why I'm so excited to tell you that Brilliant has a course all about it. Brilliant's Dark Energy course will teach you everything you need to know about the stuff, from the theoretical minimum to concepts like the cosmological constant and quintessence. It's a beginner's course, so you don't need to know anything about physics already. You can take it at your own pace and learn as much or as little as you want. Brilliant courses are super interactive. They make learning really fun. So if you want to learn something cool about the universe, go check out Brilliant. Thanks for watching.